The first question is, what is faster than the speed of light? Anybody? Got anything? Okay. Yes and no. Okay. Speed of light is approximately 1 billion kilometers per hour. And under Einstein's theory of relativity, nothing with mass can even travel at the speed of light, and only light itself, or photons, can travel at the speed of light. And so why is it impossible for us to ever travel at the speed of light?
Because we have mass.
Okay, and how does that affect it? We have mass, yes, that is the answer. But why does mass matter? When we get close to the speed of light, our relative mass increases. Okay, so the faster you go, the heavier you become. And therefore, more energy is needed to move you forward. Okay, so you can never ever travel at the speed of light because you just become too heavy. Okay, so as you can see here, little rocket, it's traveling slow, travels a bit faster, it gains 5 kilograms, goes a little bit faster, 50 kilograms, and then it goes up exponentially. The universe, though, is expanding faster than the speed of light. But this is not actually breaking Einstein's theory of relativity. This has to do, it is actually expanding. So it's not traveling through the universe, it is stretching. So it is stretching and stretching time as such. So that is the only thing that theoretically is, but is not faster than the speed of light. If one could travel at the speed of light, how fast can we go around the Earth? Around our own planet? And no, you cannot answer this because you know. How fast? Come on, take a guess. How fast? Speed of light around the Earth. 3 seconds? Do we have any other offers? Less than a second? 10 seconds? Okay, at the speed of light, I can go around the Earth just under 8 times in 1 second. 8 times, 7.49 times in 1 second. What about to the sun? If I'm traveling at the speed of light, how long would it take me to get to the sun? 8 seconds? 10 seconds? Okay, any other thing on 8 seconds, 10 seconds? Do we have any other offers? 5 seconds. Okay, it would take approximately 8 minutes to reach the sun. Okay, you got to remember the sun is a little bit further away than the circumference of the Earth. How long would it take at the speed of light to travel to the end of our Milky Way, or from one side of our Milky Way, that's our galaxy, to the other, at the speed of light? Come on, take a guess. Let's have a guess. A week? Years? Okay. How many years? No, okay, he says 2.2 billion years. Just one side of our own galaxy. 5 minutes? 5 years. Okay. It would take approximately 100,000 years. 100,000 years to get from one side of our galaxy to the other side. That is our galaxy, the Milky Way, what you see in the sky. What about to the next closest galaxy, Andromeda? How long do you think it would take to get to the next galaxy? And we are assuming on this one, for simplicity's sake and mathematical sake, that both galaxies are still and traveling in the same, or traveling at least in the same direction at the same speed? How long? 2.4 billion, 1 million. Any others? 10 million. It takes approximately 2.5 million years if you are traveling at 1 billion kilometers per hour. Okay? So that's a really fast car. What about to the end of the universe? How long would it take us to reach the end of the universe? Never do it. Any other guesses?
If it's technically somewhat expanding faster than the speed of light,
Okay, yes, you could never reach the end of the universe because there is no end, there is no edge. Even the visible part of it is expanding faster than the speed of light. So even though you're traveling at 1 billion kilometers an hour, you could never reach the end of the universe. At the moment, there are certain galaxies that we are still seeing, but soon they will disappear because they are traveling too far. Our ancestors in the future will see a different sky than what we see now. How many stars are in our Milky Way, in our galaxy? Come on, guesses here. 100 billion. A trillion. There are 100 billion stars just in our universe. And remember, these are stars, so they are suns with planets. So every star you see, most of them will have planets. Stars are suns. Some are bigger, some are a few thousand times bigger than our sun. So they have planets, they have orbits. There could be, you've got to times that 100 billion by about 10 to reach the approximate number of planets. And that's excluding the moons circumferencing the planets. So if each star was a grain of rice, you could fill 2,500 Olympic-sized swimming pools. Just to put it in a little bit of perspective. How fast are we traveling through the universe? How fast are we moving right now? Rotational, yes, okay. So we're rotating around the Earth, around the sun. Anybody want to add to that? Okay, so we have the Earth's rotation. That's going at 1,600 kilometers per hour. Then we have the Earth's orbit around the sun. That is at 100,000 kilometers an hour. Then we have our solar system's orbit around the Milky Way. And that is at 700,000 kilometers per hour. And then we have the Milky Way's movement through the universe. And that's at over 2 million kilometers per hour. So, blows your hair back when you're traveling that fast. How fast do you think the International Space Station is orbiting around the Earth? It is traveling at about 28,000 kilometers an hour, which means it's rotating or orbiting the Earth every 90 minutes. Okay, if you were driving one of Elon Musk's new super duper flying car that he's trying to invent, and you're traveling at 300 kilometers per hour, how long do you think it would take you to get to Orion's Belt's closest star? So Orion's belt, you all know, it's the three stars. You have them in the northern hemisphere and the southern hemisphere. Okay, the closest one, how long do you think it would take you to get there? Traveling at 300 kilometers an hour. 20 years. Okay, your math was not very good. Stick to hard. It would take you just over 4 billion years if you're only traveling at 300 kilometers an hour. And you actually can't, because you have to travel to get out of Earth's orbit, to break out of the gravitational pull. You need to travel at 28,000 kilometers an hour, otherwise you will never leave Earth. Because Mintaka is about 1,200 light years away. Now, Orion's belt looks like they're all clustered together. They are actually separated by a few hundred, and in some cases a few thousand light years. So they align up, but they're not together. How much larger is the sun compared to the moon? 100,000. Anyone? The sun is 400 times larger than the moon, but it is also 400 times further away. And therefore, they often look like they're the same size. Okay, here's a thought that might keep you up at night. Every star you see in the night sky is a sun. Some are hundreds times larger than ours, some are smaller. Nearly all of them have planets. Not just one or two, but entire solar systems. Just like ours, orbiting, spinning, waiting. And here's the staggering part. The closest star to us, other than the sun, Proxima Centauri, is over 4 light years away. Even if you could travel at the speed of light, it would mean that you were traveling for 4 years just to reach it. Most of the stars you see, they are thousands of light years away, some tens of thousands. You're not just looking into space. You are actually looking deep into time. Some of the light hitting your eyes tonight, this light left the star before man was on Earth. You are seeing the past. Not metaphorically, literally, you are seeing the past. And if that's not a mind-blowing fact, there are more stars in the universe than grains of sand on all beaches in the world. And more planets than you could even count. So tonight, when you look up at the sky, remember, you are not looking at stars, you are looking at a galaxy full of suns. Each one with its own story, its own world, its own chance to be just like ours. That's me.